Hey everybody, it's Miss Street. I've changed locations. I'm down in my basement, and which it's a finished basement where we watch TV and stuff. Cause it's raining outside, and Miss Street loves the rain. It's a true story. I do, and I like to stay in my blanket. So I got my blanket wrapped around my feet, cause I'm cold. But anyway, we are ready to subitize. Here we go. 10 groups of 4. So 10 and 4 are our factors. What's the product? 40. That's right. Repeated equal groups. Repeated addition. Get ready. That was easy. 1 group of 5. So our factors are 1 and 5. Not 5 and 1. And Miss Street, you know what? I had a connection last night, texting with one of my colleagues. And you know what? 1 and 5 are different than 5 and 1, even though they have the same value as 5. The commutative property tells us that 1 times 5 is 5, has the same value as 5, and 5 times 1 has the same value as 5. But listen to this. Parents, teachers, I feel like I'm lagging. I'm not sure. But if you had to do a training, okay, or sit through a seminar, or kiddos, if you had to do an online class, which you're doing, but there's a difference between doing the online class on one day for 5 hours or doing the class for 5 days and just 1 hour each day. I know. Blows your mind. Mine too. True story. Last one. 2 groups of 10. And 2 groups of 5. Miss Street subitized the 10. Whoops. Sometimes I go too fast. 2 and 5 are our products, and are our factors, and our product is 10. And remember, 2 times 5 and 5 times 2 that's the commutative property. That tells us they have the same value, but their magnitude is completely different. Remember, Miss Street's always talking about quantity and magnitude. So would you rather go to the beach for 2 days, 5 hours each day? Or would you rather go to the beach for 5 days for only 2 hours a day? That's different, okay? So Miss Street's going to turn off that nice calming music. I just felt like we needed to calm down. All right, here we go. Using my handy dandy wall right here. So we're working on 3.NF.3, represent equivalent fractions with area and length models. We're composing fractions, we're decomposing fractions, and that's helping us with our related fractions. And so, and we'll go into related fractions when we do our problem. And so yesterday, Miss Street showed you how we relate to, we have to remember the numerator and the denominator has the same value. Then they equal 1 whole. Okay, so if this is 1 whole day, that's 1/4, 2/4, 3/4, 4/4. That's an entire day. Okay. Also, we have to look at whole numbers up to 4 as fractions. So we have to be able to look at 2 as 8/4, or 3 as 12/4, or a number less than 2 could be 6/4. It's a true story. And so Miss Street showed you guys, we looked at which one of these represents half, and we went through, and we know by related fractions that 2/4 has the same value as half. We did use our fraction bars and our circle discs for that. And then Miss Street showed you how we connect this up to 4. So we have 4 rectangles, and we had 7/4, okay, shaded. So when we look at that, we put that together so we can see it. This is the rigorous part because it's all scattered, okay? This is kind of an easier way to see it. And boys and girls and moms and dads, Miss Street can tell you right now, this is a good way to start, but our kiddos need to be able to see it this way most, okay? So we looked and we said, well, if we take those 4 whole rectangles and we know 7/4 are shaded, that means 1 whole rectangle and 3/4 of the whole fourths is shaded red, okay? So now we're going to do our eighths. And Miss Street started on this, and then I was like, whoa, Nellie, slow down, Miss Street, because I want to show you how we get related fractions with the area model. So I know that these circles are partitioned into 8 equal areas. So I know, here I go again. Here I go again, my own. I know if I have half, if I partition it in half, I get a fourth. If I partition a fourth in half, I know I get 1/8. So Miss Street knows that if I take my circle and I partition it in half, then I partition it into fourths, what's happening to my areas? They're getting smaller, even though I'm getting more areas. So now I know I take the fourths and divide them into halves, and that gives me 8 equal areas. So let's do that to our other ones. Half, fourth, eighths. I'm taking each area and partitioning it into half. Half, fourths, eighths. Halves, fourths, eighths. All right, so we said the other day that this figure shows 14/8 are shaded. Okay, so I want to look at that, what that means up to our 4 whole numbers. Okay, 14/8 are shaded, but let's look and see what that is. So I know there's 8 equal areas here, so that's 1 whole circle. 2 whole circles would be 8 and 8 would be 16. I'm only looking for 14. So I know I can shade in 6. Here we go. 1, 2, 3, 4, 5, 6. So this shows us that when we look at the wholes up to 4, that we can see 1 whole 14/8 represents 1 whole and 6/8. Okay, so that would be, if we were doing a number line, we would go 1 whole, which it's not partitioned into eighths, but we know if we it's partitioned into fourths, and we know if we partition, let me get you closer, the street's gonna blow your mind right here. We know if we partition each of these fourths in half, let me do a different color, that will give us eighths. So 1, I'm partitioning those fourths into halves, so that will give me my eighths that I'm looking for. And I'm looking for 1 whole and 6/8. So I know that there's 1 whole. So if that's 8/8, that's 1 whole and 6/8. So that would be 1, 2, 3, 4, 5, 6. Look at that. That is very interesting. Do you see the connection to that? 7/4 has the same value as 1 whole and 6/8, which is the same thing as 14/8, which we just did on the other side. I know you might need to pause here and take a moment, and that's okay. You can pause the video at any time, okay? So, have a new problem for us today. Boy, Miss Street's getting warm up moving around like this. And I get excited because I love teaching math to you. And I love learning with you. Okay, so here we go. Here's our problem. Let me get it up there. Which circle is 3/4 shaded? And Miss Street always wants to make sure I show an area model, or I use it with my fraction bars, and a length model, and show it with a number line. That's very important to be able to do both ways, okay? So let's look at this first one. Boy, Miss Street. You know what? Miss Street's going to take this sucker on the wall, because that's where I am right now in life. It's true. And I'll see if I can get you up close. I mean, that's pretty good. Okay? Not really. Let me move these over. I know. Mysteries all over the place. And it's okay. All right, here we go. That's a little bit better. You can see. Hang on. Move it down. All right, and we're ready. So, if Miss Street doesn't shade it up with her own shadow, so let's look. Which circle is 3/4 shaded? So let's look at A. A lot of times teachers will say, let's start with D and work our way up. So we can do that too. Let's count. We have 1, 2, 3, 4, 5, 6, 7, 8. So that's our denominator because that's how many equal areas there are in the whole circle. How many are shaded? We just did that. 6. 6 out of the 8 equal areas are shaded. Let's look at C. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 equal areas total. How many are shaded? 1, 2, 3, 4, 5 eights. Okay? So let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 equal areas. How many are shaded? 1, 2, 3, 4. And this goes right along with what Miss Street was trying to show you with these guys. Okay? Because a lot of times we want to see it easily like this. But a lot of times we're going to see it where it's all mixed up like this. And we have to determine what we're looking at. Okay? It's hard. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 equal areas. I have 3 of those shaded. So I'm going to go back to my question. Which circle has 3/4 shaded? Miss Street, the answer is not there. There's 3 8s, 4 8s, 5 8s, 6 8s. And Miss Street can tell you, I bet my bottom dollar that you people would choose 3 8s because it's got a 3 on the top. Raise your hand, would you? Look at it again. You would. Miss Street knows it. It's a true story. And it's okay. That's why I'm here to help. And so are your teachers. So we're going to look at this. The answer is there. And we're going to look at this with our area models, which are our fraction bars. So we're going to move it on over. I've got those in another chair. Here we go. Oh, thank goodness. Okay, so here I have my rectangular model and I have my circle discs, and either one that I use is fine. But I have to think about my related fractions. And when I think about my related fractions, every single one of these is in eighths. So when I think about related fractions, which ones do I know go with eighths? Halves, fourths, and eighths. Halves, fourths, and eighths. Thirds and sixths are related because they all of these fractions, the common theme to get a related fraction is half. So if you take a third and partition it into half, you're going to get 6. But you can't take a fourth and partition it in half and get a third. Okay? So basically the main theme here is all of these fractions, the halves, fourths, and eighths are related because they are related by half. They're a multiple of each other. And the thirds and sixths are related because 1/6 is half of 1/3. And so here we go. We're looking for which circle is 3/4 shaded. So I'm going to put my whole circle here. Can you see it? Oh, thank goodness. Yes. Okay. And I'm going to use my eighths to determine, okay? So I know I want to look for how many eighths do I need to make 3/4, because that's what I'm looking for, 3/4. So right now I'm just going to use my eighths and my fourths, okay? So number 1 has us doing 3 eighths. 1, 2, 3. I should have done my 3/4 first. So sorry. Miss Street's going to get with the program. So I'm looking for which one has the same value as 3/4. Can you see? Okay, good. So now I'm going to do 3/8. So I'm going to go 1. Oh, it's going to move on me, and it's okay. 2, 3. Does 3/4 and 3/8 have the same value? I'm going to go with negative, Ghost Rider, because look here, where there's more of the fourths, correct? It's true. All right, I'm going to put my 8ths over here, leave my 3/4 because that's what I'm looking for. How many 3/4 are in, how many 8ths are in 3/4? So my next one has 4/8. So I'm going to get my 3/8 back on here. 1, 2, 3, and here's 4/8. Oh dear, Miss Street's moving them. Okay, so do 4/8 and 3/8 have the same value as? Nah, there's more of the fourth, but we can see that 4/8 and 2/4 have the same value as 1/2. Related fractions. All right, let's look at the next one. 5/8. So here I have my 4/8. I'm going to add an 8. It's moving, but it's okay. I mean, here we go. So does 5/8 have the same value as 3/4? I hope you're saying no, because there's more of the fourth there, even though, can you see that right here? There's more of the fourth. So the last one says 6/8. Ready? I'm going to add one more 8 because I had 5/8. And what do we notice? Do 6/8 have the same area as 3/4? It's a true story. Ding, 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 ding. It does. It covers the same equal area. So Miss Street is going to put my paper back on the wall. Here I go. I'm taking way longer than I'm supposed to. Big shocker. Okay, and I know that 6/8, I want to use a different color. 6/8 has this 3/4 and 6/8 is the same value as being shaded. Okay, so again, if Miss Street wants to look at it this way, I can partition this circle into half. Then I partition the half in half. So here's where my fourths are. Do you see? Here's 1/4, 2/4, and 3/4, which mean they have the same value as 6 of the 8ths. And again, we want to show it on our number line, and thank goodness Miss Street already has one because I am running out of time. Big shocker. Let me get a different color. We'll go with, I don't know. Oh dear. Come on, Miss Street. Pick a color. Any color. I'll do orange. Okay. So when we look at this, we're looking at 8ths, and we just did our 8ths just a moment ago when we were looking at our other problem. So let's look up at 6/8. Here we go. I didn't label them, but here's 1/8, 2/8. This is 3/8, 4/8, 5/8, and look here, 6/8. What do you notice? That 3/4, do you see it right here? 3/4 and 6/8 have the same equal space or the same area. And so that's what makes them related fractions. That's a true story. So Miss Street hopes you guys have best day ever. I'm sorry I took so long. Again, if you need to pause the video at any time to process what I'm saying, it's okay to do that. And just let me know what you think. I'll see you back tomorrow. I think we'll continue with NF3 because Miss Street has some more rigor. Make it harder. Hope you guys have a great day.